Welcome to this quick start course on Physna's physical AI search and comparison tools. This training can be experienced with hands on the keyboard while connected to a Physna environment. Please reach out to your account team to gain access to a Physna tenant. The off-the-shelf demo environment we will be demonstrating does not include Physna's supplier catalog, MCP server, or reality compiler. Your Physna account team can discuss and demonstrate these advanced features upon request. We recommend you pause this video playback anytime you wish to try the examples. A physical DNA holds the encoding of the geometry, features, relationships, and material characteristics of a physical or virtual object. If all assets in the physical and digital worlds came with their physical DNAs, every company using Physna would be able to search for partial and complete 3D assets, as well as more complex multi-body 3D models without solely relying on labels or descriptions. This means being able to find where any object, its duplicates, and other similar assets are located, as well as how they relate to each other. You can also make predictions based on a deeper understanding of objects through their geometries, features, relationships, and material characteristics. This quick start training is designed to help you experience firsthand the power of Physna's physical DNA in under 10 minutes. New users begin by receiving an email to create an account. If you have questions, contact your Physna account team. You can sign in with single sign-on or an email and password of your choosing. From then on, access Physna at app.physna.com using your Chrome browser. The main landing page displays folders that contain PDF documents, images, and 3D models in formats such as CATIA, Siemens NX, PTC Creo, and open standards like STEP, JT, and others. To the left of the screen, you can initiate searches, comparisons, and reports, and the top right brings contextual help information, user and system status, administrative and setup features. The second layer of icons display hints when you hover over them. Physna is designed to be easy to use, so anyone from design engineering, manufacturing, logistics, and maintenance can derive value from its information. To better understand and experience the power of physical DNA, let's explore the contents of this Tesla demo folder and begin by searching with one of its 3D models. Using a match threshold of 80%, Physna searches its database and identifies a model with an 83.77% match. Let's compare the two. At first glance, they appear to be the same single-body 3D object, but using Physna's X-ray mode to inspect their complete geometry, we can clearly see the difference. One model is a Tesla valve, and the other is not. Any other tool that is based on shape search and visual match algorithms fails this simple and yet revealing test. Physna's physical DNA is critical to the accurate matching of parts. When it comes to searching with one or multiple images, Physna leverages the richness of 3D models by using their physical DNA to enhance computer vision. You can start with a photo, a screenshot, or even a simple sketch. Let's try it out. You can download an image with which to test Physna's 2D to 3D unique enhanced computer vision technology powered by Physna's DNA. Click on the search button, then click on the search bar and type in the word NVIDIA. Click on the NanoDev Kit image that shows up and, once you get to its detailed information page, select the download option to download its .png file. Click the search button to the left of the screen and on the plus icon to upload one or multiple images of an item you're looking for. Let's use the NVIDIA Nano PNG file. Physna automatically segments the image, allowing you to focus on what matters and ignore what doesn't. You can also crop the image or use a freehand lasso to isolate a specific area of interest. From there, Physna ranks the results in the order of most probable match. In this case, Physna identified your image as a heat sink. We have transitioned seamlessly into the world of 3D, exploring at the speed of thought. Using part-in-part search, Physna reveals higher-level systems that contain this heatsink. You can also continue navigating visually through related 3D components to discover other parts of interest. Let's see how the Compare tool can be used to address an out-of-stock situation. Search for a turbocharger using a 1D text search. Click on its 3D twin and navigate visually to the bolt you need. The graphical user interface lets you select, hide, explode, and isolate groups of related components and get to the exact part you're concerned about. You find that the bolt you need is not in stock. So you search for a suitable substitute with the same dimensions and material characteristics. We found two candidates. Both are in stock and match the type of steel we're looking for. Let's compare the less expensive option to the bolt we need and let Physna show us how they differ. The plus sign seems to not be functionally relevant. That's for an engineer to decide, but Physna can further show that there are no other differences between the two bolts. No calipers needed because geometric precision shows exactly what is different. We can close the loop by checking whether this alternate part fits in the turbocharger. By using part-in-part search and adjusting the match threshold, we can find and compare the turbocharger to the candidate bolt. In overlay mode, we now have visual confirmation that up to 8 bolts need to be acquired to service the turbo. Now imagine you work for a company that produces farm tools, a brush cutter, a chainsaw, and a wood chipper. Your job is to compare supplier pricing or perhaps verify whether common parts are being used across the various machines you sell. Let's navigate to Phyzna's reports section. The duplication report is preset to guarantee 100% geometric matches. The simplification report is preset to find similar parts at a 95% similarity threshold. This is useful for finding candidates for standardization or complexity reduction initiatives. Custom reports allow us to control all comparison parameters. They need a name, percentage thresholds, and a selection of folders containing the models to be compared. 21 times 49 times 65, that's over 65,000 possible part matches. Let's check the results. We are getting a better deal on spark plugs from AutoZone. Looking at the butterfly valves, we see a single supplier. That's a potential supply chain risk. The wood chipper can simplify its bill of materials by adopting one of the two similar screws. Manufacturing cost reductions, lower acquisition costs, higher purchase volumes, and reduced maintenance costs are all within reach. Note that all reports are downloadable. Starting from a foundational physical DNA layer, Physna delivers precise, deterministic search, comparison, and analysis across all data types. Across the full spectrum of physical AI use cases, from robotic simulation and training to digital twin asset management, Physna enhances intelligence at the asset level. Its foundational physical DNA layer gives every physical and digital 3D asset a geometry-based identity, enabling more precise search, comparison, classification, validation, and part reuse across complex AI-driven environments. This concludes this quick start training. You're now in possession of a powerful tool to leverage the physical DNA of 3D assets across both the digital and physical worlds.